4. This is the last page of the 5.7 notes. I want you to try number 1 and number 4. Sit down, Felix. We're already started, okay? We're doing number 1 and number 4. We gotta get going. So we have our notes out. Okay, so this is the last page of the 5.7 notes, right? It's right before 5.8. We're going to do number 1 and number 4. So I'm giving you about 30 seconds-ish. Try out these 2 problems. It's a review of what we did last time. All right, so if you go to the section 5.8, it's the page before 5.8.
We did seven yesterday.
It's what we did yesterday. So if you go to 5.7, go to the end, the last page. Okay. Really, this is on the bottom. Keep going.
Oh, right here. There's 2 pages in this.
Okay, so we're doing number 1. Yeah, well, I mean, it's in section 7, 5.7. Okay. Trying number 1 and number 4. So you can look in your notes for number 4 for the order of doing it. So looking at what multiplies to negative 21 and adds to 4. That's the question for number 1. Okay, so what adds to positive 4 multiplies negative 21. So it tells you if we're adding to a positive, multiplying to a negative, one of them has to be negative, one has to be positive. Really, the only things that multiply to 21 are 1 and 21, or 3 and 7. So I need it to be a positive number. That's why I have x plus 7, and then x minus 3, because if you add them, you get 4. You multiply them, you get 21, negative 21. So the first part of this exercise is solving the equation. Okay, so we factored, and we have to set each of these factors equal to 0. If I set x plus 7 equal to 0, all right, subtract 7 on both sides, we get x is equal to negative 7. And if I set x minus 3 equals 0, add 3 on both sides, we get x equals 3. Those are my solutions, but that's not the full directions of the problem. Right? We have to state the number and the types of roots. So, Jacob, there's 2 roots, and what are the type? What's the type? Exactly, there's 2 real roots, right? So just getting you ready for this. Okay. Do we have enough time to try number 4? Okay, let's give it a shot together then. So number 4, we're trying to state the possible number of real zeros, positive real zeros, negative real zeros, imaginary zeros for each function. So we're going to use the rule of signs, right? Descartes rule of signs. So the number of positive roots, right? This one's the easiest to find. You don't do anything to the function. You just look at the function and you go through and see how many times you switch signs. So I start positive, I go over, oh, I switch to negative, and then I stay negative. So there's only one sign change. So there's only one possible positive real root. Okay, to find the number of negative, what do I have to do first before I count? Adi? Yes.
So the 3x cubed, is it not a positive nor a negative?
It's a positive, because if you can assume it's a positive because there's not a negative sign in front of it. Okay, done. Well, okay, so we get 1. 1 or 0 are our stopping points. So I have 1, so I'm done.
That's just 1.
What? So I have one positive real root. So if I want to find the number of negative, the first thing I have to do is change the signs in front of any variable with an odd exponent. So this 3, that's odd. Here, they don't have an exponent, but you can assume it's 1. That's an odd. So I'm changing the signs in front of odd exponents, and then I'll go and count how many sign changes we have. So f of negative x, right, this is how we have to count for our negative real roots. I had a positive 3x cubed first, so now I'm going to change the sign, so it's negative 3x cubed. I'll leave the next term, x squared, because that's an even exponent. 2 is even. And then the negative 8x, I have to now change the sign, so it'll be positive 8x. And then I have a negative 12, and I leave it alone as negative 12. Now that I have switched the signs of the one I must, and I can go through and count how many sign changes I have. So I'll count how many sign changes we have. So I start negative, and then I turn to positive,
1.
and then positive to positive, positive to negative, so that's 2. So if I count 2, I'm not done, right? You can't stop subtracting 2 until you're at 0 or 1. So I have to subtract 2. So I'll either have 2 or 0 negative real roots. It's kind of like when I woke up this morning. I knew I was going to wear this D. Toledo shirt, right? I had 2 options of pants. 1 shirt, 2 pairs of pants, that's 2 combos. 1 positive root, 2 negative roots, there's 2 possible combos, right? I can have 1 positive and 2 negative, or 1 positive and 0 negative, 2 combos. So figuring out the number of combos tells you how many rows we're going to have on our table. So I have to make my table, plus, minus, and I. Right? Each of these columns stands for the number of positive roots possible, but I just summarize it as a plus. So we said we're going to have 2 combos, so I just have to have 2 rows. What? Okay. What's the total number of zeros I can have, though? What's the total number I should have? 3. How do you know? How do you know? It's the largest exponent. So we'll say it again. The degree of your polynomial is the largest exponent, and that's how many zeros total you should have when you add up your positive, your negative, and your imaginary. So if I go through, I know I'm going to have 1 positive root for sure, but then I can either have 2 or 0 negative. So imaginary roots are always your filler, right? That they always get you to your number. So the first row, if I take 1 plus 2 plus what number is equal to 3? 0. Yep. It's just a little puzzle game. So the bottom line, 1 plus 0 plus what number is 3? 2. That's it, right? Your answer, the thing I'm looking for, is literally this table. But you have to justify the numbers. You have to show your work over here. So me showing the dots and the counting, right, the little skips, that tells me, okay, you understand what it means to switch signs, yes?
Why does it have to equal to 3?
The total number of zeros is the highest exponent, it's the degree. Since I have a cube, that's the highest, yes?
How do you know to only do 2 combos?
Because there's only 2 combos, right? I can have, remember when I had Jordan and Felix stand up?
Yeah.
Yeah. So if I only have 1 shirt and 2 pairs of pants, okay, I have only 2 combos, that's it. Because if I say, oh, you know, this shirt and jeans, this shirt and the same jeans, that's not a different combo, it's still the same one. I want as many different combinations as possible. So I only can have 1 positive and 2 negative, or 1 positive, 0 negative. There's only 2 choices. All right. Yep.
Let's say the positive is a 2, so it's 4.
I have 4 combos, yeah. Because you, let's see. So if I had like 2 positive or 0, 2 negative or 0, I could have 2 and 2, 2 and 0, 0 and 2, or 0 and 0. 4 combos. All right. So this reviewed Descartes rule of signs. Hopefully you notice I mostly assign odds. That way you can check your answers in the back. Like, that's the idea. I don't want you to get them wrong. But also, because they are odds, and because Slater exists, and you know, there's all these other apps that now do your homework too. That's funny. Okay. Like, you have to show work on your homework. You can't just write the answer unless it's like specifically impossible to write it another way. Okay. So if you have questions about that, you can always like come to Boner so we can discuss it. Question?
Sorry, I don't know what questions.
That's fine.
Why is it for like the negatives 2 or 0?
So we have 2 sign switches, and it's always the number of negative zeros are always the number of sign changes or less that by an even number. Right. So it's like, what the heck are you saying? Either you have to have either 0 or 1. If you're not 0 or 1, you have to keep subtracting 2 until you're at 0 or 1. So if you have an even number of sign changes, you have to keep subtracting 2 until you're at 0. If you have an odd number of sign changes, you keep subtracting 2 until it's at 1.
Is that why it's 3 or 1?
Yeah.
But
because-
for 2, you can't do 2 or 1.
So imagine
it's
you're
just 3 or
driving
2.
home. You're in your car. Oh, you stopped at a stop sign, right? You're going to get out, shut off the car. You're like, no, you're not home. That's just a temporary stop. It's exactly, right? So let's say you find 3. You're not home. You have to keep subtracting 2 until you're at 0 or 1. So I'm not really explaining why we have to do this.
Wait, so if we got 5, then it would be
That is awesome.
subtracting 2 until you got 1. Right?
What?
Whenever it's an odd, no matter how big
You
the
keep
odd
subtracting
number
2 until you get
is,
1.
and if it's an even, you're
Keep subtracting till 0.
So it can be 10 and you're subtracting 2.
Yeah, so
And
then
you have to
if
subtract
you count
by-
10 if you count 10, you have to have 10, 8, 6, 4, 2, and 0.
So you can only subtract by 2.
Yeah.
You can't subtract by any other number.
Well, I want you to subtract 2 and just keep doing it. That way you don't miss any numbers. Because what happened last year, if you would have something like 6, people would put 6 or 0, and they're missing the 4 and the 2. Does that?
Right.
Yeah. So the reason I'm trying to make this as straightforward as possible. Just keep subtracting 2 until you're at 0 or 1. Yeah. I mean, I could make it more difficult and explain the real reason why we do this, but you don't care. I know you don't care. I just want to tell you the stuff you have to know. That works. Yeah. When we study exponential functions, I'll give you lots of real world stuff. This one, cool. I gotta teach you it. Make it as simple as possible, straightforward, so you don't mess up. All right, 5.8.
So funny. Can I just say this for a minute?
No.
So funny. So funny.
No. I've asked you a couple times.
But we leave the time at the end of class.
How about at noon? That works for me. Okay. So, 5.8. See? Exactly. My joke's not funny. When you ask me, can we have a chill day, that's not funny either. 5.8. Rational zero theorem. If I give you a polynomial function, like this one, and I ask you to find all the zeros, I want you to fully factor it. I'm pretty sure at least half the people would immediately be like, nope, I'm done, goodbye. Right? I know you, right? No, what the heck? Where do you even start? There could be, where do you even start? Okay, is 1, is a half, is 5? You have no idea what to check, how to start. Don't touch him. Come on. Rein it in, okay? Rein it in. Self-control. Here we go. Are you 17 or 18?
What?
Are you 17 or 18? 16?
17.
17. Okay, so you gotta rein it in. You gotta rein it in, okay? Okay. You know what happens when you're 18? You become a full adult.
Yeah, I can go to jail.
Yes. Let's rein it in. Let's rein it in, okay? I'm trying to help you. Learn how to control your impulses, so that way you don't go to jail. That would be great. That's really bad. That's really
Miss Amber
morbid.
literally just told me that.
Oh.
Our meeting just now.
That's,
She's like, you have to work on impulse.
Does this mean
control
I'm an
or you're
adult?
gonna end up in jail.
You told you were gonna end up in jail?
Yeah, she's
Oh,
like,
God.
Yeah, you'll have to call her back. You keep doing it like
For jumping in a pool?
No, she's called trespassing.
it is. There's a kid who I grew up with who got charges pressed against him for trespassing into the city pool because he jumped in.
That's the
But
same.
it's our
This is
school
D.
pool.
Toledo Jewish High School. So
You're paying to maintain that.
Okay, I'm not having this conversation.
Why are we?
I'm not having-
I can maintain the pool.
I'm not-
You can't jump in.
I'm not having this conversation. We're going to continue with class. Okay, so I have this polynomial function. You have no idea, where are the x-intercepts, right? What are the solutions? I have no idea. You have no idea where to even start. For instance, if I tell you, I'm going to send you on a scavenger hunt and you have to find the town I lived in, that I was born in.
Nebraska.
You have no idea where to start. But it's because I gave you a clue, right? I told you I was from Nebraska. You had some place to start with, right? You had an initial clue. Okay, this is you. The point's over there. We're missing the point, okay? Literally, I am trying to help you understand why this is a thing, the rational zero theorem. if I give you a clue, like, oh, I grew up in Nebraska, that gives you someplace to start. The rational zero theorem gives you someplace to start when we're trying to figure out the zeros. Because it literally gives you a list. It gives you a list of all the possible rational zeros. Instead of having infinite number of numbers, we have like 10 to choose from. And we know at least one of them will work, right? That's the idea.
Why can't we just have like 2 dollars and then just not have to go
Goodbye. All right.
I thought you were telling me to take a walk. I was like, no way, that's my thing.
No, I don't. No, I don't. I like try not to send people out unless I'm like,
Have you ever been stumped
if
by
I'm
like
done.
math?
What?
Like when you were learning math and you were just like, I can't.
Yeah, in college. All the time.
Well, of course, it's not MIT.
That's true.
Massachusetts.
Okay.
Institute of Technology.
But it was hard because I speak English with very little accent, and I don't talk about tofurkey. My G's and my P's and my 6's and 9's all look different. I am very clear and I articulate. So when I was trying to learn math, when I'm trying to like learn something new and I can't even understand what they're saying, that was so hard.
Why were they?
And they went really, really fast. They don't show all the steps. Okay.
Yeah, dude.
So, ready? I'm going to explain the rational root theorem. So the rational root theorem, we use the constant term at the end, and we use the coefficient of the leading term. So we're using the leading coefficient and the constant. And if you, oh my god, I wrote P twice, this is a Q. So if you are quite fancy, right, you will have a big exponent, so that's the Q. The Q is your leading coefficient. If you're like pretty sad because you don't have a variable, that is your constant at the end. Yep. There you go. There's one way to remember. If it's dumb, cool. Figure out your own way to remember it.
You're sad
Okay. So, here's the deal. In order to find the rational roots, you have to find all of the factors of P.
What do you
I'm waiting till you're quiet. All right. Being patient. Be like 3 more seconds before I mark you down for talking. All right, we just gotta focus. We have a lot to do today. Okay. So, to find the... Okay, go hold together. So, when we're doing the rational root theorem, we do P over Q. Except, we have to take every factor of P, so all the factors of 40, right? 1, -1, +2, -2, +4, -4, +10, -10, +20, -20, +40, -40. And divide by every single factor of Q. Well, what is my Q here? 6. So I have to divide all of those by 1. Then go through and divide all those by 2. Then go through and divide all the factors of 40 by 3. And then go through and divide them all by 6. Yeah. But guess what? Having 40 options to choose from is better than infinite. Okay, there you go.
And that's why we have a thing called photo.
Cool. You can't use it for a test or quiz. And that is the majority of your grade as well as the final. So 100%, that's why homework is worth very little, is because of that. And Slater, and the fact people have tutors who will do the homework for them.
And my tutor does not know math. Like, I swear to God, he
Why
tells me to do it.
do you pay him?
He's good at English, but I don't do English anymore.
Oh, okay. Okay, yeah, let's do this one. Okay, ready? P and Q. P and Q. Let's go through the back row. Kaden, what's my P here?
24.
24. What is my Q, Jacob? 1. Awesome. So let's list out all the factors of P. Done. Give me some. Here we go. Factors of P. Factors of 24. 1 and 24. 2 and 12. 3 and
I hate when there's P's and
4.
No, 3 and 4 is
Yeah, why isn't it like
3 and 12. 4 and 6.
8 and 3.
8 and 3. 12 and 2. And 24 and 1. Wait, what the heck? Why am I writing plus or minus?
Because they can't be plus or minus.
Right, because, ready, I can have positive 1 times 24, or a negative 1 times negative 24 is positive 24. That we have to include all the positive and negative. Now, we just went through Descartes' rule of signs. What if the rule of signs said we don't have any negative roots? No No zeros that are negative, right? Up here, remember when we went over this guy? What if we said, oh, there actually are 0, absolutely no sign changes? You know what this would happen? You know what happened?
All
It'd be wrong.
Cooper, louder.
all the negative factors.
Yeah, I crossed out all the negatives, and then we just cut our list in half.
Jitsui.
That's where, yeah, Descartes comes in handy sometimes. Okay, so then we have 1, 2, 3, 4, 5, 8. We have 16 different options, right? All the plus, all the minus. At least one of them is going to be a root. There we go. That significantly helps us. Okay, what are my factors of Q? I think in my Carly. Factors of Q.
Q, 1.
Yeah, it's just plus or minus 1. All right, so if I go through and apply the rational zero theorem, it's when you take every factor of P and divide by each factor of Q. What are all these numbers divided by 1? Who said this? 3. She says it's the same, so it is the same. I literally write the exact same thing. So shortcut, instead of writing plus or minus every time, you can say plus or minus outside the parentheses. That would help you a little.
You don't use the minus, right?
Huh? We do. We didn't do Descartes rule signs for this. But I'm showing you where like these two can come together and like help you out.
So is that the answer?
I boxed it. It's the answer. Because the example says list all the possible rational roots, right? That's a list. Do not solve. We're not trying to solve. We're just trying to apply this. Yes, Jacob.
So Q isn't 1. You can divide all of them
Yep.
6.
Ah, speaking of something that's not 1, let's go to B.
Awesome.
Ah, what's my Q for B?
3.
3. Oh my goodness. Okay. All right, let's go with this. So this is my Q. My P is 10. Am I good to scroll over? I think you're done writing. Maybe. So try to list out all the factors of Q and all the factors of P. Try this one out now that we've done one together. Try to list it out yourself. Find all the factors of 10, and then find all the factors of 3. Alright, hopefully we're done. So we list out all the factors. I like writing them in order because it makes it a little quicker, making sure I don't forget any.
Why do you want
Because 1 times 3 is 3, and negative 1 times negative 3 is 3.
Why do you also use factors?
All the factors of Q, all the factors of P.
Is it final
Okay, let's go through. Ready? I have to take all the factors of P and divide by plus or minus 1. Turns out those are exactly the same thing. Alright, when I take 1 and divide by 1, it just is 1. Take 2, divide by 1, it's just 2.
You can do the parentheses thing with that?
You can. Okay, so all of these, this is when I was dividing by plus or minus 1. But you have to divide all the factors of P by every factor of Q. So now I have to go through and divide every single one by 3. Yeah. To take all of them and divide by 3. So I have plus or minus 1/3, plus or minus 2 over 3, plus or minus 5 over 3, and plus or minus 10 over 3. I hear you. I acknowledge your opinion and complaints. They're acknowledged.
Numbers.
So what this means, if you plug this into your calculator, you plug the original function into your calculator, every single x-intercept that you find on your calculator will be on this list. That's the idea. Every single x-intercept that's real, that's rational, will be on this list. You won't have an x-intercept that's not on this list, right? So this kind of like narrows it down for you. Because if you can at least find one factor, it's much easier to find the other factors. And that's what we learned in 5.6. What are we doing here? Do you have your notes?
Yeah.
Do you have them out? No, you need to have them out. You need to be following along. There's participation points for following along. Please get out your notes. I wrote it on the board. So you can use the shortcut with the plus or minus outside the parentheses. Okay, so now we're going to put everything we've learned together. We're going to use Descartes rule of signs, which is 5.7. I'll wait. You have your notes? You need to get them out. If you're not going to get them out, you need a piece of paper, you need to follow along and write down what we're doing. Okay. Yes.
Why is it like a third of this?
Well, 1, so you're taking all of, okay. This is when you're dividing by plus or minus 3. If you take 1 and divide by 3, it's a third.
Wait, but why are we doing that?
Because you have to take every factor of P and divide by each of the factors of Q.
Oh, okay, so the first one, the problem before, it was just 1, so we could just leave them all,
Right.
but because that's a 3 and
We have-
3. Okay.
Yes.
Okay, that makes sense.
Okay. Okay, we're going to put everything together. 5.6, we use the synthetic division to see if something was a factor. We're going to use 5.7 with Descartes rule of signs. We're going to use 5.8, which is a rational root theorem. Right, so we're putting everything together in one swoop. Okay, so I'm literally going to be walking you through the problem. You see how this is scaffold? That's the idea. So, x to the third minus 6x squared minus 13x plus 42. So use Descartes rule of signs to identify possible patterns of roots. So I just have to find out how many positive roots will there be, how many possible positive roots. So I need to go through and count how many times the sign changes. So this is positive to negative, that's one change. Negative to negative, negative to positive, that's a second change. So there are 2 sign changes. So I could possibly have 2 positive real roots. But I'm not done. You have to subtract 2 until you're at 0 or 1. So if I subtract 2, I'm at 0.
So you can't really have 1 or 0. If it's 1, it's just 1. Correct?
So if you have a even number of sign switches, you can have 2, you can have 0. But if you have an odd number, you can either have like 3 or 1. It depends how many sign changes you have.
But you can't have 1 or 0,
Right.
right? Okay.
It's always going to be 3 or 1 or 2 or 0, right? Like those are what goes together.
Okay.
You can't have 1 or 0 because you're always subtracting 2.
Is it 1 and 1 then?
What?
It's just 1.
No, it'd just be 1. Okay, so let's try the next one. Why do you keep turning around? Literally every time I look up, you're looking back at Jacob. So, I don't know what you guys are doing, but you gotta like knock it off. Okay. So I need to go through and I need to find out how many negative possible real roots there are. So, what do I need to do? This will be the second time we've done Descartes today. How do I do this? Done?
You have to change the size of the variable to double the odd.
Exactly. Variables with odd exponents. Okay. Variables with odd exponents. This is a 3. This is secretly a 1. You have to change the sign that's in front of them. So I have f of negative x is equal to negative x cubed minus 6x squared plus 13x and plus 42. Now I can go through and count how many sign changes there are. So I go negative to negative, negative to positive, positive to positive. There's only 1 sign change. So if you have 2 pairs of shirts you're deciding between and 1 pair of pants, there's really only 2 combos you can wear, only 2 outfits. So that tells me how many rows I need, because I have to list out all the different combos. I could have 2 positive and 1 negative, that's the first row, or 0 positive and 1 negative, that's the second row. So don't say the answer out loud, but think. How many total zeros should we have? right? What should every row add across and equal? 3. Okay, cool. So you had a little time to think. It's 3. So the first row across, 2 plus 1 is already 3, so I am not supposed to add anything, so I write 0. The second row, 0 plus 1 is 1. In order to get it to 3, you have to add 2. So this is powerful because it tells us we for sure have one negative real root. Like we're going to have one negative, and that's it. Okay. Do we have questions over this one? Cool. So your practice test is, well, I already gave it to you guys. I mean, it's pretty similar to the real test. I'm not going to do what I did on the partner quiz and give you the exact same problems, but it'll be similar. Cool. Your partner quiz, if you look at 1 through 10, and then the 5.3 practice we did in class, I didn't even change the numbers. It's the exact same problems. Yep, 10 of the 14 problems we did exactly in class, but the solution's uploaded and screencast. So, and it was a partner quiz, so I was trying to give you guys like a little, good wiggle room at the beginning of the semester. That was the goal. All right, let's identify the possible rational zeros. This is what we just did. Okay, ready? This right here was 5.7. Now we're learning. Now we're applying 5.8. So 5.8 possible rational zeros. So I need to know what my P and my Q are. And I have to list out the factors and then do P over Q and all the possible rational roots. Oh my gosh, so much work. So let's come up to the function. What is my P and what is my Q? Jesse.
Your P is 42, and your Q is 1.
Exactly, Q is 1, so that makes it nice and easy. P is 42. So when I'm listing out the possible factors of Q, it's just going to be plus or minus 1. But we need to list out all the possible factors of 42. So 1 and 42. You can make a little T-chart. It will help you be organized. 2. Does 2 go into it?
Yeah.
2 and
1.
21. Does 3 go into it?
Yeah.
Yep. 4. Does 4 go into 42?
No.
No. 5?
No.
6?
Yeah.
6 and 7. And then we're good. We have all the factors listed for us. So we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 7, plus or minus 14, plus or minus 21, and plus or minus 42. So if I want to do P over Q, I will take every factor of P, and I'll divide by Q. So 1 divided by 1, 2 divided by 1, 3 divided by 1. Oh, literally anything divided by 1 is itself. So I just have to copy those factors of 42 down.
If it's 3 over 3?
3 over 3 is the same thing as 1. Yeah.
But there's already 1. So you don't want it.
Right. Are you doing the next page? No.
The cube part. You're gonna.
Oh, well, because I only have 1. Yeah. All right, do you have questions over this one? Okay. So I'll wait till everyone's written down because I want to make sure people are listening when I say the next part because it directly deals with your test. Okay, so this next part, I took some of these notes I took from Algebra 2 notes. So my pre-calculus are learning this exact thing right now. So this next part says use synthetic substitution to find a real root. So you have all the possible rational roots. That is what these are right here. So what I make my pre-calculus kids do, they have this polynomial function and they do synthetic. They pick any one of these numbers, positive or negative. They go through and see if synthetic division tells us if it's a factor or not. And then if it doesn't work, they have to go to pick another one. They may do 5 different synthetic divisions before they actually find one that works. That's a lot of work and that's a lot of time. Like, that's a pain in the butt. So for you guys, what I'm going to do, you have a calculator and you know how to use it, right? We've been working on calculator skills. A real root means x-intercept. So if you plot this polynomial function, right, plot this x cubed, blah, 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 graph it, menu, analyze graph 0, you can find one of the roots. I'm literally telling you, this is how you can like cheat the system. I want to help you so you don't take 50 hours doing this. That's a waste of time, right? Not productive for us. So I want you to, what? Oh no, we're going to use synthetic substitution.
I like synthetic.
But instead of having you guys do synthetic substitution like 5 times, I'm going to tell you, hey, find one of the roots with your calculator, and then you can do synthetic substitution to prove that it's a root. I'm having you do 1 synthetic substitution instead of 5. Oh my gosh. Yes, I'm literally telling you. I'm helping you. Whatever. Maybe it's a bad idea.
No, I wasn't trying to do that.
Okay, over it. So, for instance, this is what I would make them do. Let's pick a number. I'll pick 1, right? I'll pick 1. I'm going to go through and I'm going to see, is this a root or is it not? So I'm literally plugging in x equals 1. See if it's a root. Okay. So I have my polynomial from up top. So I'm going to put in all the coefficients. Oop, that's a positive 42. Let me see, is this a root or not? So bring down the 1. Okay, multiply, add, multiply, add, multiply. Uh-oh. Uh-oh. This isn't going to work. What the heck? Right? This is not a remainder of 0. So guess what? X equals 1 is not a root. All right. And then they have to keep going through until they find one that works. That's a pain in the butt. I literally just told you, I want you to use your calculator, find a root. If you plug in this polynomial, this cubic function, menu, analyze graph, 0, and you find one of your x-intercepts, you do that, okay, guess what? 2. 2 is going to be a root. We know x equals 2 is a root because you just found on your calculator. What I'm going to require you to do is, like, instead of having to do 4, 5, 17 different synthetic substitutions, just do 1. Prove to me it's a root. Okay, I just want to see if you can apply this method, right? You have to have the work to support your answer. So I put 2 here, 1, -6, -13, and 42. Go through. No surprise, it's going to work. Yay, no remainder, it means it works. So I'm telling you right now, I'm trying to cut the work for you. I'm trying to help you not spend so long. Okay, because you're going to have to know how to do synthetic substitution anyway. I think it is overkill to require you guys to have to do it 10 different times. So I'm telling you right now how to solve this problem. Okay, if I'm wanting to find a real root, find one with your calculator on the graph. Then plug it in and show me it's actually a root. That's it, right? That's it. Not too bad. This is where my pre-calculus students take, this is the time waster. This is what burns them on the test, is if they take too long with this sort of problem. So I don't want to burn you guys. I want to give you as much time as possible. I think I made the test like 15 questions. Your practice test is 20. So yeah, it's all good, right? There's a couple of bonus questions. It's doable. We just have to make sure we do the homework, do some studying. We'll be good. Okay, so this one, use synthetic to find a real root. I boxed it. We have our root, but you have to have the synthetic substitution for your work to prove. If you just write x equals 2 and this is 4 points, I'll give you half a point. You have to have your work. You have to show. You have to show synthetic substitution. If you plug in, that's wrong. You can't use direct. It says synthetic. That is one thing that we missed on our quiz. All right. And lastly, part D, right? So it's scaffolding. All of this is the same problem. Now, we want to examine the depressed polynomial. What the heck is a depressed polynomial? It's not sad. It is the... If I would write this out, I would have x squared minus 4x minus 21. This is the depressed polynomial from our synthetic substitution. Since x equals 2 is a root, it goes evenly. This is what remains once I divide by the factor of x minus 2. Okay, so examine it, find the remaining roots. So right now, I know x squared minus 4x minus 21 times x minus 2 is equal to my original function. So I knew that x equals 2 was a 0, so in order to write it as a factor, I set x equals to 2 minus 2 on both sides, and I have x minus 2 equals 0. Well, this is what we started the class with yesterday. If it's set equal to 0, like this is the factored form of my root x equals 2. That's why I spent like 5 minutes beginning of class yesterday going over this. So x minus 2 is a root, and if I multiply is a factor. If I multiply by the depressed polynomial, I'll get back my original polynomial. Okay, so we're trying to find the remaining roots. I already know this is a root of 2. I already found it up above. What I need to do is factor x squared minus 4x minus 21. How do I factor this and solve? Anyone?
Oh, don't you multiply the 21 add to the 4?
Exactly. Multiplies negative 21, adds negative 4.
I have a question. For C, we only need to find one real root?
Yeah, it said find a real root. Yeah.
What test is it gonna be?
I'll look at the test after we're done with this one. Examine it. So D is examine it and find the remaining roots. So we found one. Now you have to find the remaining. So since we found one real root, guess what? There has to be a second real root. Okay. What adds to negative 4 multiplies negative 21?
Negative 3 and positive 7.
So x minus 7, x plus 3, and if you solve these, you see x equals 7 and negative 3. So these are the remaining roots, right? Remaining roots. So we're not going to do the next example because it's not something I'm going to ask you about. We'll put it that way. Huh? On the test. The next one is not one I'll ask you about on your test because it's a lot of fractions. It's not the level I try to challenge you guys, but I'm not trying to kill you. So I'm not doing the next example. What we can do is we have, I think, 10 minutes left. Yes. So 10 minutes. You need to be working. Alex, no one has finished Alex yet. You have to be working on Alex or homework. You can work on homework. 10 minutes, knock out half a homework assignment.
Hey, let me tell the story.
Okay. No.
Yeah, please.